Yes, we would like to introduce to you our approach, how we make it possible to define algorithms and mathematics in a new way in software. We have 3 parts. The first part is my part, and I will basically explain to you how our software Pacewell works, what advantages we have with the software, and what you can do with it, and also what advantages it has against other software solutions. For the second part, I hand over to Professor Michael Kraxner from the MCI Institute. He's in research and development and technology transfer and responsible for a lot of projects and devices where artificial intelligence is one of the key things in the future. And we have worked together with this institute on neural networks, and we will present a setup there. And for the last part, I hand over to the inventor, Jörg Könning, mathematician and informatic scientist, and he will present an ideal architecture for artificial devices, local intelligence, and presents example use cases. Yes, we know there's a lot of buzzwords here going on: big data, IoT solution, robotics, and of course artificial intelligence. And part of all this buzzwords and modern trends is of course software development, and the core of it are algorithms, mathematical models. But the way to implement mathematics and algorithms in software hasn't basically changed since the 1980s. So if it comes to individual programming, it costs a lot of efforts to parallelize calculations and to do error handling, to handle overflows, underflows, to manage the development of algorithms in larger teams. And and also if you have specialized software, they have shortcomings in particular if it comes to closed intelligent systems, where you only have limited processor performance and memory space. And this is exactly where we want to present a new way of integrating these algorithms, which will provide various solutions, an innovative approach for these devices. And as Pacewell, our mathematical software library, of course, the basic demand is that it is a calculation master. What does it mean? It should handle the most complex models very quickly, safely, and precisely, and it should run on any hardware and on the server. So be also adaptable for IoT surroundings. And how does it work? Yes, with Pacewell we support the most complex models, which means that the number of signs is not limited, the number of variables is not limited. You can easily present situations, most complex situations like neural networks, with our product, so you're not limited in any sort of space. And we also support the Boolean logic, so you can also have like decision trees and and present the most complex situations. Apart from that, Pacewell calculates very quickly. Why? Because we have automized parallelization of the calculation, and we use innovative caching methods, which means that you don't need to spend a lot of efforts programming the parallelization for yourself. We do it all within one package within our library, and so we can present calculations which consist out of 500 million signs within a few milliseconds. We calculate also very safely and precisely. What does it mean? Apart from a calculation value, we also present the upper value and the lower value. We have integrated interval mathematics. Why is that so important? There's branch solutions, for example, GeoSoftware, or also software for engineers, who only get one calculation value, and as we know, hardware doesn't really calculate precisely and accurately, and sometimes you have system rundowns because of this rounding areas. We additionally provide the upper value and the lower value of the calculations to support a better judgment of the situation. Pacewell also runs on any hardware, starting from, and is compatible with any compiler, starting from systems from the 1990s. Why is that? Because it has been developed over 20 years, so we are backwards compatible with any system. And our library is very small, so we support local intelligence on closed systems. For example, like on virtual reality classes, for example, or drones or whatsoever. And due to the separation of logic and calculation, or due to the fact that the calculational part is separate from the main program, we also support IoT setups, centralized programs. And because we fulfill all these facts, of course, we support that your applications are competitive, and also we ensure that you can create innovative products with it. We have also further highlights, because within Pacewell, you don't need to complicated describe your algorithms. We use the standard mathematical notation, so it's like you can easily describe your algorithms. And this is why with our program we also support the algorithms TÜV, or the transparency on algorithms that has been discussed largely nowadays. And we also support it, that you can also present your algorithms to other to public institutions, for example. Then Pacewell is free of any other software, which means that you don't need to fear that we use any other, that we have incorporated any open source components or anything. So you're not forced to publish it or to pay further license fees, or you're dependent on another party. It's a totally self-developed product. And of course, it's protected. We have by trademark and by patent. And other aspects of Pacewell is that it's easy to implement in your software development process, because apart from the fact that it's a super computation program and it supports transparency and it's free of other software, third parties, of course it can be very easily and quickly integrated in your development process. Because we support an easy integration of mathematics in your individual programming. We support fast maintenance and requalification of the software, and we deliver a universal programming interface, so you're not limited to any languages or operating systems. It's totally flexible. You can use it anywhere, and we offer a universal interface to other tools because of the textual interface. We can connect different systems, so you can use, for example, one system like Julia or Python and get the learned algorithm on a local intelligent device. And easy integration of mathematics. Yes, we have a very simple API, and of course we also provide a source code sample where you can see that it's really simple to use and simple to integrate. You don't need training. You can immediately use the software model. And fast maintenance and requalification, we have that because it's written in textual language. So let's assume your model changes because in your device you have another sensor and you want to integrate that sensor and you need to adjust your mathematical model. It can be very easily done with Pacewell because we have it's a short line of description, or it's a line of description of the mathematical idea behind it, and you can adjust it very easily. It's not compiled within the source code. It's easy accessible, easy readable, and therefore also easy adaptable. It's a universal programming interface. As I said before, it runs on any operating system and it can be integrated into any programming languages, so it's a universal tool. You're not limited to any development surroundings. And we have, to the textual interface, you can combine different tools, and this is something that we want to present now, that we have used Julia in the context of artificial intelligence and learning networks, and we connected it with Pacewell to set up a total new architecture for local intelligent devices, which we will later present. So as we offer all these aspects, we support a fast development, a fast software development, and also not only in the development itself, but also in the maintenance, and we enable innovative product concepts. And I have also brought with me some metrics which shall give you an idea, that Pacewell combines a lot of different characteristics, which makes it unique and special and shows its specific strength in various situations. For example, the fast definition adaptation of algorithms combined with the fact that the logic and computation is separated supports the fact that you have intelligent IoT devices, for example. And the fact that complex and accurate computations, if you take, for example, scientific software, it takes very, very long for the scientific software to calculate. But with Pacewell, you can have the most complex calculations, and you can have it fast because we have the automatical parallelization of the computation and caching methods there. And we even deliver very accurate computations with the upper and lower interval value. If it comes to size and the capability of being integratable into other devices, we also offer an advantage here because it's very small, and also with the local intelligent devices, you only have limited system capacities. And other tools are bigger in size, it's more difficult to integrate them, and even some of the tools are not able to run on, for example, an ARM processor. They're not flexible between different operating systems. And this is why we also offer a big advantage in this area with Pacewell. So what do we want to do with Pacewell? We want to create value fast in the development of products. We are part of different gremiums, and currently we are having a few partnerships where we examine the strength of Pacewell in different areas, for example, in the area of setting up IoT system, for example, in the area of local robotic systems, and also, of course, in the area of artificial intelligence. And to go a little bit more into detail here, I would like to first hand over to Michael Kraxner, who is responsible for the development of a lot of exciting devices that will be more and more interesting to implement artificial logic in the future. So, please.
Okay. Thank you, Claudia, for this very nice introduction. It's for me a little bit unconventional that I start now without going into deep technology, because I'm used, if I go to a conference, that I'm talking about technology in detail. But now, as Claudia said, I'm talking about some devices, what we are developing. What is, if I'm talking about we, that's what it looks like where I'm from. So I guess you know this in this. So, okay, that works better. Thank you. That's the region where I'm from, not actually exactly at the top of the mountain where this picture is taken, but it's MCI, it's Management Center Innsbruck. It sounds a little bit strange. I'm definitely sure you feel about that. But MCI is a subsidiary of the University of Innsbruck. So the University of Innsbruck said in 1996, we need to have a speedboat. We need to have a speedboat university which is able to develop courses and give education for people who are working in industry. And so they raised up a spin-off called MCIs. And what is MCI doing? MCI is mainly giving education programs for bachelor, master, and PhD programs, but they are heavily working together with industry as well for example, with Pacewell. If I start now, I do not go into deep into the deep technology. I just want to tell you some projects which we are working on. So that you have an impression, we only have about 80 people working in this research field. We do about 100 projects a year with a total turnover of approximately 8 million. So it's not that high number, but we pick out our corporations very well. So I picked out one research group. It's called electronics. My colleague Ronald Sterz is leading this group. And what is he doing in there? Just a short expression. We call it EAL. It's something like the Emerging Applications Lab. He's designing applications. Which applications? For example, excuse me, I was a little bit too quick. Applications for Infineon. Everybody of you knows Infineon, and I guess you know what they are doing. They are working in semiconductor industry, and they have lots of engineers, lots of people working in research. But finally, what they do not have somebody who is designing and picking out consumer products. They do not talk too much to young people who will buy a drone or something like this. That's what they followed behind this goal. They came to MCI and said, let's design an emerging application lab where we bring up new products. You use young people, young students who bring up new ideas, and we develop together new products for semiconductor industry. Finally, we are actually working heavily on drones, but not now anymore. This is some years ago. I think everybody knows drones. They could fly, I know, but they use a lot of artificial intelligence. They use a lot of radar technology. They use a lot of power electronics. Finally, actually, we design a lot. We bring a lot of work into gallium nitride. So this is a gallium nitride drone center. Actually, they're working about 20 people within this group where we design new products for a high consumer market. These are just some impressions that you get a feeling about that, what we are doing in there. What else is coming out here? We designed some suitcases which will be spread all over the world for universities. Exceptionally for universities, where they get a dev kit, and with this dev kit they can design new drones, new development stuff. And they can work with stuff from Infineon, as for example. A next approach, where it's also filled up with artificial intelligence, the mixed reality. I want to stop here the video, because first of all, I think you know the AR, VR, and MR, the mixed reality systems. But everybody of you probably know that there is a problem. The problem with the steering, the gas stick steering. It's not working quite well. Is this right? You touch around like this. Okay, now it's working, or now it's working, things like this. And what everybody of us will have to use, or is willing to use, is finally a pen, a small pen like a mouse for the virtual reality. You just use a pen, and you have a preciseness actually of ±1 millimeter. So it's very accurate, and finally, it's not here just to play around, but you can now work really different. You can use it in calculation, you can use it as an architecture, you can use it in several other applications. Just a short impression. We were sitting next together and said, what's the problem of AR? Finally, it's the gas stick steering. And so that's what came out. Just a small pen, you can use it like the lady she's doing, or you can use it quite professional, for example, in designing and construction, or you can use it for calculation, and you just draw in the air, and it's working really, really smooth with a preciseness, as I said, of ±1 millimeter in the moment. So, as I said before, I'm used to talk about technology normally if I go to a conference, and now I did something like a salesman did. That's not my job in reality. But I wanted to do it in that way that you get an impression what we are doing and what we have done with Pacewell. So what we did, we took some neural networks and we extracted the equations. We extracted masses of equations, for example, face recognition, recognition of lavatory, recognition of letters and things like this. And what Pacewell is doing with this stuff, I will hand over to Jörg Könning. He's the technician at Pacewell. And finally, he's doing now my job because he is going into deepness.
Thank you very much, Professor Kraxner. And thank you very much, Claudia. So the problem with AI today is you need to equip these kind of devices with artificial intelligence. And in our case, it's more local intelligence that we want to bring to these devices. Local intelligence means that you are independent from the cloud in special situations. So the question is, what is an ideal architecture for that? So an ideal architecture has to fulfill certain characteristics. First of all, these are very small devices, so the main program should also be very small. And it should be system independent because you want to be independent of the main processor and of the memory, so you don't want to rely on a certain hardware architecture. And this allows you to deliver quick software updates and to be flexible on the software-hardware options and be very fast in development time. Because key for these kind of devices is bring them to market quickly. So that's a given fact. Sometimes you only have a few weeks or months to deliver these devices. Then second characteristic is you need to be able to compute complex algorithms local. Why local? Because cloud is expensive, because you need battery to connect to the cloud. You might need a SIM card to connect to the cloud, of course, and all this is expensive. And then you have also a cloud partner that you need to pay as well. So to avoid going online, you need this local intelligence. Yeah. Third characteristic is that you need to separate the complex algorithms from the main program. Why? The main program should at least be as stable as possible for a given time, because if you update the main program all the time, then you need a very complex and risky update process. And if you just update the algorithms that might, for example, be stored in the file system, then this update procedure is not that risky. And of course, you save a lot of time in bug fixing, verification, and also in the certification. So for these kind of devices, certification is a huge time impact. So the fourth characteristic is that the mathematics on these devices must be absolutely correct. And finally, these devices must be safe. Yeah? So you don't want these devices to be hacked, for example. And normally, or usually, these characteristics contradict each other. So what is then the architecture that we are proposing? So with Pacewell, you can define and use a very simple architecture. So for example, on a drone, or whatever kind of device, a request or event comes in. And then there is this very small main program that handles all the input values. Input values can be sensor data or audio data or video data or pixels, yeah? So images. The complex algorithms are stored in the file system, and due to the request and event, this gets computed, and in the end, you will get to a decision and reaction, and the calculations are very complex. So for example, with MCI, we use neural networks, but you can also use decision trees or whatever kind of machine learning algorithms you want to do. Of course, neural network is an important aspect on machine learning and artificial intelligence, but it's not the only aspect. Yeah? So for example, we have customers that want to do gesture recognitions. Yeah? Then, as said, you can do easily software updates over the air because everything, like Claudia said, is handled in texts to Pacewell. So this is pretty easy, and you can zip it and just do a very small bunch of updates. The decisions and reactions, you create an audio log and you update it to the cloud. This is definitely also necessary, and to combine it with the user data. Like we did with MCI, you can do external creation of your mathematical rules, whatever this is. You can do neural networks. For example, we did this with Julia and Python, but you can use also MATLAB if you like to, or even more cloud-based solutions. And then finally, we are working with a company that is an expert in blockchain. So we are proposing that you secure this cloud data with blockchain. So this is what we call local intelligence. But you can do this even smaller. Like Claudia said, the Pacewell library is written in C, C++, and it's only 200 kilobytes and runs on every processor you decide to run it with. And of course, you can run it on a sensor. You can create intelligent sensors in the future with Pacewell. Yeah, so you put just machine learning on top of it, and that's it. Other example use cases, of course, all of you know this kind of device. And the problem with with these kind of devices is that, for example, my son, he's 9 years old, and he talks to this device, but the device doesn't react on a keyword. So there need the machine learning algorithm on this device to detect the keywords must be updated. And of course, you can update the firmware all the time, but it's more clever to just update the algorithms. Yeah? So because you don't have then this costly, time-consuming, and also the risky flashing of the firmware. The next example is here a fridge. You open a fridge, and the fridge detects objects that you hold in front of the fridge. And of course, a simple solution might be you put a modem solution in the fridge, and then it goes online, and then it detects all the objects that you put in front of the fridge. But the more clever approach is to identify if there is an object that needs to be identified before that. So you can save a lot of battery power and also a lot of costs. The same for face recognition. Of course, you should not try to identify a face in a picture in the cloud if there is no face on the picture at all. Yeah? Then finally, a very nice use case is you have a system that you are already selling to the market, and due to certain restrictions or rules, you need to put an additional security on top of that. With our solution, you can easily put a watchdog in hardware and software next to this main solution. Just add the sensors to it, and then you do a predictive analytics on top of that. So you can prevent the main system for being unstable or for having the not correct or for not doing not correct behaviors. But there are definitely many more examples. For example, you could think of medicine devices that you have at your body, yeah? So that you put a neural network on it, and this automatically detects your health case. So finally, our target is to create value fast. And you can download our Pacewell SDK for free from our homepage and use it for a limited amount of time. And this is supported by the Digitalbonus Bayern. So you definitely save costs if you order it. And yeah, that's all. And I hope this was interesting for you.